Let's pray together, shall we? Father, we thank you for these marvelous bodies that you've given us, and all of us want to take better care of them, which is your plan and your blessing. So give us insight, and when there are areas that we can work more wisely, help us to determine to do that, Lord, we pray in Jesus' name. Amen. Just a little catch-up from last night in case it wasn't clear. Maybe I should ask somebody to articulate it, but maybe I'll just do it. The problem with insulin resistance and dementia is that the high levels of insulin. Do you remember that insulin resistance makes your body make more insulin? And for a long time, the blood sugar is still normal, and no one knows that you have more insulin in your blood. Does that make sense from what I said last evening? So that elevated level of insulin is a pretty clearly understood now to be a big issue in dementia. And because 70.5% or 0.4% maybe it is of Americans are overweight, all of those people have insulin resistance. If they had that long enough, they might eventually be diagnosed with diabetes. Are y'all with me on that? Because the body can't, the pancreas either fatigues or cells actually die so that it can't keep producing more and more insulin. And that all of those years before it's finally diagnosed as diabetes, dementia is being undergirded. It's an awful thing, but that's the case. And what is the number one risk factor for dementia? Obesity, overweight. I'm sorry. Diabetes, which in most cases is preceded by too many pounds. I'm sorry? I did.
All went hand in hand, and they go together.
Yes, although people can be overweight for quite some time before they're diagnosed with diabetes, as you all know. All right, the cancer conundrum. There's some really good news and some kind of bad news, or really bad news. I heard Dr. John McDougall. I think almost every one of you raised your hand, and you heard about him since then, if you hadn't before. He gave a lecture, kind of a disturbing lecture, and the title of the lecture was I can't remember the word now he used, but the fallacy of early detection. Because by the time first of all, let's just understand that, and I think you all know this, all cancer is started by a single cell. I'm missing your attention when people walk in here. I'm sorry about that, but follow me carefully. All cancer is started by a single cell somewhere in your body that becomes cancerous. And we'll look at how that happens. It takes about, on average, 100 days for that cell to copy itself. So there are now, how many? 2 cancer cells. Another 100 days, and how many there are there? 4. Doubling. It takes 10 years. Now, some cancers grow more rapidly than others, but on average, it's 10 years before that tumor is about half the size of a pencil eraser. And this is the very, very bad news. It is virtually without exception that long before any tumor is ever discovered, cells have gotten away. Are you all with me on this? This is the bad news. And that's what John McDougall was talking about. Early detection doesn't change the fact that cells have already started growing in other places in our bodies. Not good news, but that's just the way it is. So the fallacy of early detection, what that brings up immediately for females, of course, breast scans. And I have several friends actually that are radiologists, but one of them, I sit with him in his office, well, in the not his office, but the room where the equipment is. And he looks at X-rays all day long and diagnoses all kinds of either okay or not good issues. And you ladies must be aware that there is decreasing emphasis on breast scans. Am I correct? Are you aware of that? There's two reasons for it. Early detection is not going to change the course of cells somewhere else in the body that have started growing. And the other thing is, are you aware of this? That there's a great deal of overdiagnosis. Are you aware of that? And then they start treating you, which means surgery or chemo or both. And so it's an interesting world we live in. I still support the idea of mammary scans, but there are issues there that we can, in lifestyle, do much better than making sure we get scans all the time. My college roommate, one of them, his daughter was diagnosed about a year ago with breast cancer. And by the way, breast cancer kills 40,000 females in America every year. The largest killer of women. Prostate cancer, another reproductive gland, if you will, kills 30,000 men in America every year. These are big issues, but there's a lot we can do, as we'll see, particularly with lifestyle kinds of things. So his daughter, Neva, you might help me a little bit. When we were eating lunch with them about 3 weeks ago, she had never done a self-exam. And I don't know why somebody said to her, you should, and she found this big lump. And the poor girl, by the time that was found, she was in stage 4. There was cancer in other places, and you know all that tragic story. There are some cancers that respond quite well to chemo these days. We're getting better and better. It's still a horrible course for most people, in most cases, depending on the drug that's being used. But there are some. I have a friend, he was a pastor when we've worked together, older than I, maybe 10 years, that got a type of cancer that the chemo is 70% effective at making the cancer disappear. And he was in that category, and he's doing quite well. Now, when we say cancer comes back, that's an interesting term. It's not that it went somewhere and then it decides to come back home. It just means that not all the cancer cells got killed. And one of them, or more of them somewhere, over that 10-year period, or less, depending on how many of the cells were killed, is starting back on its way. So those are some sad things. There's some interesting good things that we're going to look at a lot of them this evening. This is a picture, this is an actual micro photograph of a cancer cell that has been recognized by a killer T cell. That is a type of T cell that actually bores a hole in the cancer cell, and that immediately causes its death because chemicals leak out and balances are, and suddenly the cell is no longer functioning. This is an actual photograph. We have known this for 35 years, this feature in the cancer world. Here's a diagram of how this works. On the left is a killer T cell, and it makes little vesicles in which it puts a protein called perforin. Now you might say, where do scientists get all these names? I'll just tell you that those little particles in that vesicle, is this amazing or not what our body does? Actually, are the perforating, you'll see how it works, the perforating instrument in boring that hole. So the scientists with great originality named it perforin, like to perforate. So this killer T cell fastens itself to the target cell, the cancer cell. Actually, killer T cells will kill other cells if they need to be taken care of, but we're thinking of the cancer at the moment. And the reason it fastens itself, seals itself all the way around, I'll show you in a moment. But after this cell leaves, it has puncture. Can you see kind of a dotted line there? That's representing a bunch of holes that the killer T cell made in the cancer cell, which of course brings its demise. Let's go to the next picture. Well, let me just trying to see how to do this in the least amount of time. I'm going to show you in the next picture just this region right here. Are y'all with me on that? So it'll make sense to you. Well, I was going to avoid those transitions, but here we go. Yeah, the oval is what you're now seeing in this picture. Are y'all with me on that? So here's the vesicle with the little perforin things in it. And this is one just like it, only when... and by the way, can you see there's a double wall here? And this is the double wall on the killer T cell, correct? And when a double wall touches another double wall, it's a little bit like two soap bubbles that used to blow when you were kids and suddenly they were one. There are controls for this. So this is a simpler picture. But this is how this thing suddenly causes an opening where these can come pouring out. Y'all with me? And imagine now they're circles here, but as they come to the killer T cell, they become little kind of a post. And the proteins, which as you know, work because of their shape. When they get next to each other, they connect, but they actually connect at an angle. So the next one is at this angle, and then this. So what do they form? They form a circle, which ends up being a hole in the wall of the cancer cell. Got it? Like a little grommets, dear, yeah. And there's 2 or 3 of them that the artist has pictured, and you can see this. You can see the circle forming, correct? And there's one that's just starting. Now, the reason that the killer T cell has to fasten so carefully, as I showed you earlier, is that these things, if they're let go, they'll go out and kill all the cells around. So it's got to seal, kind of a circle seal, if you're following what I'm saying, because we're seeing just a flat piece of it here. Then the other issue is those little guys can turn around and poke a hole in the killer T cell. Now, why the Lord designed it just this way, you'll have to ask him in biology class. You and I are going to be in biology class in heaven. And there's a lot of questions students raise that teachers don't know the answer to. You all know that. But not there. And I used to teach electronics and physics and a lot of things like that. And one of my favorite things was to say to the student when they asked a question and I would answer it, then I would say, "Want to see?" And we would set something up, and let them actually watch it happen, if we could do that. Now, you can't watch electrons travel around, but there's ways you can figure out where they're traveling. And so, want to see? So what happens is, that's my white arrow. The killer T cell actually makes another kind of, here it is, in another vesicle, it makes little proteins that, what did the scientists name that protein? Where did they get that word from? It's protecting the killer T cell from itself. So it's a pretty elegant thing that's going on in our bodies. And every scientist in this field believes this, probably 10, 20, 30 times every day in your body and mine. A cell somewhere becomes a cancer cell. Killer T cell just takes care of it. And the question, of course, is why does that ever not happen? We don't have a total answer to that, but we have remarkable things, folks, in terms of lifestyle that seem to support the system and make it work like it's supposed to. We could discuss this thing for an hour, I'm just going to show you that one of the reasons the killer T cells don't always work, there's a special system here. This is a cancer cell. And I'm sorry, it's a special cell that's in this process, and there's several other things here. There's a major histocompatibility function and all kinds of stuff, so that this T cell becomes activated and can now do what we saw on the screen. There are things that inhibit that, and one is an anatomical barrier. Just too many pounds in our bodies restrict circulation and could be a barrier for this T cell to connect here and become activated. There could be other kinds of barriers. Maybe something would grow somewhere, even if it wasn't a cancer, that would get in the way somehow. But that's one thing. Another thing that happens, they name these things. This is deletion, where the T cell decides to kill itself. The word for that is apoptosis. Anybody heard that word? Apoptosis. When a cell self-destructs. And all of our cells have that capacity, and there are times when they need to do that. But here's the time when, because things don't work just right, that killer T cell, instead of becoming an activated T cell to do the things we saw, dies. The killer T cell can go through these processes here and not quite get activated, and so it doesn't do its job. So scientists have discovered things that interfere with this. We're not going to get into the detail. I just wanted you to kind of have a sense. Let me just peruse with you, and most of you know most of these things, but I think it's worthwhile. Prevention issues, normal weight. You might not know this. This has only been out for about 2.5, 3 years. The number one risk factor for cancer is too many pounds. I wish you all would have gasped. Is that a big deal? And you think about the percentage of Americans that are overweight. So, and by the way, we haven't emphasized this. I think you get the point. If you're struggling with extra pounds and you put yourself on a whole plant regimen, it is so easy to lose weight. We just have example after example. It will work. And of course, you know what whole plant means, so I won't belabor that. Activity. Just everything else unchanged, just activity lowers the risk of cancer. It's probably because of circulation, but it's just definitely activity. You all know about smoking cessation. Colonoscopies, when I was a younger man, maybe 35 years ago when we started doing these kinds of things almost 50 years ago, but the number one killer of black men in this country was colon cancer. The number two killer of white men was colon cancer. We now know how to eliminate at least 95% of colon cancers. That's colon screening, a colonoscopy. Not really pleasant, but you know the rules. If nobody in your family has colon cancer, then you should start at 50 years of age getting colonoscopies. If there's some family member within 1 or 2 generations that has been diagnosed with colon cancer, you should start at 45. It wouldn't hurt to start younger. And probably 95+% of, you probably know this, of colon cancers start in what we call a polyp. And they draw it like a little toadstool. Most of them don't look like toadstools, but it's a little growth, and it's very rare for colon cancer to start, except a certain one. There's one kind that's essentially kind of a stomach cancer and a colon cancer together. Oh, thank you for that. When you have the colonoscopy done, the physician removes each of those polyps. They have a little wire lasso, and they press a button with their foot, and it cauterizes and cuts that off. And cauterizing it, of course, there's blood supply to that little thing, correct? And so it cauterizes that incision, And then they have another little clipper that grabs it, and they pull it out and hand it to the nurse, and she puts it in a bottle, and he goes, or she goes on looking for more. There's a problem with this. It's not a big problem, but when I first heard about it, well, let me back up and say I have, 4 friends who are GI docs, gastroenterologists. And one of them especially, he and I have worked together for years and years, overseas and in this country, and I always have questions for him that come up in my mind. And I didn't know this for years, but the best clinicians miss 10% of the polyps. And I said to him when I first heard it, "Is that true?" He said, "Yeah, Jim." And the reason is, in what they call a well-prepared colon, it's completely clear liquid so they can see well. Even then, there are cases where they just don't see it. They actually can take the scope and bend it back and look. And sometimes when they look back, they see a polyp. Like I said, they're not a little toadstool sticking up very often. Sometimes it's just a little extra tissue on one of the ridges that the colon is made up of. And the sad story is, at Loma Linda University, the director of the GI lab, you know what I'm talking about, scoped the head of surgery. And 2.5 years later, that man died of colon cancer. The top guy in the university missed a polyp. It's fairly rare, but just so you'll understand kind of what can happen. But please don't avoid this, even if you've never done it yet. It has just made colon cancer just about disappear. So it's remarkable. Oh, I'm sorry for your question. So every one of those things that goes in a little bottle gets frozen, and the pathologist cuts it up into 50 slices or whatever, and looks at every slice and looks at the cells there to see how far they have progressed toward cancer. They're experts at that. And depending on what those look like, the GI doc will tell you when you should come back. It's usually 5 years if there's nothing too remarkable. Sometimes they'll even say 10 years. My mother and father were both diagnosed with colon cancer in their lives. What does that tell you about me? I'm at risk, and I have had I've done it every 5 years for 25, 30 years, whatever it is. And I make a lot of polyps. That's why that's what's going on in my father and mother's body and in mine. Neva, I don't know that she hardly makes any polyps. I had to drag her kicking and screaming into the GI lab. But I did have to encourage her more than normal to get her to do it. But because she makes hardly any polyps, the doctor, I think, told you 10 years, didn't he? When the last time we went together and we had it done at the same time. I'm sorry? It must have been. I'm sorry, dear. Yes, that's what she said. What's wrong with your twisted minds? Very seldom, unless I've never heard of one. But if the advancement in some polyp was far enough that the GI doc felt that was important, they would let you know. But normally, I'll bet you 85 to 90% of the time the doc will say 5 years. And alcohol, folks, this is probably there's nobody in this room that drinks much alcohol, but this has been published recently. I have a whole section in the manual we hand to our guests when they come. All these slides are we print colored manuals so that they can follow along and take notes. And in there is a good several-page description of the International Association for Research on Alcohol, IARC, I think are the letters. And they have published recently that even one drink of alcohol increases your risk for cancer. And every drink after that increases it more. It is a big deal. Most all of you, because of your religious convictions, aren't using alcohol, but it's worth knowing for anybody or family members or whatever. I'm sorry? Yeah, over time the risk decreases if a cancer doesn't occur from any kind of carcinogen issue. So yeah, it's a good thing if you are using alcohol to decide to stop. It's quite remarkable. The article that was published on this by that international group is quite remarkable and stirring for anybody who uses alcohol. Diabetes or prediabetes, irrespective of overweight, is a risk factor. Late menarche, breastfeeding, first child before 30 is a preventive thing. I'm going to try to stand in front of this so people on both sides can see this. To stand to the side so I can draw something. We'll look at this more in a few minutes. I think you're all comfortable with the idea that in every cell of our body there is this thing. What do we call this? Come on, folks, talk to me. What is that? That's the DNA. And there's 3 billion. 3 with 9 zeros. Actually, there's 3,200,000,000. I don't like to take so long to say it, so I just say 3 billion. And there is no exception to this. Oh, by the way, do you remember that these rungs, actually there's 2 rungs, and so you could kind of draw a little split here to emphasize that. These rungs have names, and the name is either an A or a C or a D or a K, right? No. What? Oh yeah, A, that's right. T, and it's suddenly escaping me. What's the other one? A? A's connect to, is there a D? That's crazy that I can't remember it. Anyway, G is the one I'm missing. Okay. Yeah. So, there are various kinds of mutations. I think you know the word, but just make sure you understand. It does something to one of these half rungs. The most common thing is it gets it either changed to a different letter. I should use a different color, but I'm not going to take the time. I'm just going to draw a little circle, let's say. That's a half rung, but let's say it's not the same one. That is a mutation. Y'all with me on this? And we're going to see in a few minutes lots of sources of mutation. There is no exception to this. I said it the other night. All cancer, did I even say it tonight, is the result of usually a series of mutations in the DNA. When I say in the DNA, I'm talking in one cell. Because we're talking about a cell that becomes cancerous, right? So, and I said last evening, most of us we all have many mutations throughout our bodies. And once in a while, it's a series of mutations that would make this cell become a cancer cell. Now, actually, men, little boys, like little girls, are born with the same structures in their little breasts. You guys all aware of that? But in the female breast, because the male breast doesn't ever really have this happen, there are these milk-producing, we call them lobules. There's a number of groups of these, and there's 10 or 15, and then there's a duct to take the milk to the nipple. And lining the duct, I probably should use a different color, is some endothelial tissue. And I'm just going to draw the cross-section here a little bit. I'm drawing little circles. Are you all with me? Please say yes. Okay. And at every menstrual cycle, all of these cells kill themselves. And just before they die, they replace themselves. Apoptosis, every cycle. Now, in that process of making new cells, there is an error in about 1 out of 1,000 of these rungs. 1 out of 1,000. So for every 1,000 rungs, there is a wrong half rung. Are you all with me on that? Am I kind of standing in front of it? I'm sorry about that. How many mistakes are there then? Let me put some 3,000. There you go. Let me help you. We'll just say 3 billion. I got to write it all out, I guess. I wanted to use scientific notation, but if you divide that by 1,000, what do you have left up here? 3 million. Is that correct? So you actually get 3 million mistakes every time in every cell in that lining at every menstrual cycle. And there's another helper here. We actually have, and I'll show you pictures of this, cells that come in and repair the mistakes. Not cells, proteins. I mentioned it already. I showed you a picture of a protein that travels along the DNA and fixes the mistakes. You all with me on this? And but they miss about 1 out of 1,000. So in the end, you get about 3,000 mistakes in every single cell that lines the milk duct. And as a result, 95% of breast cancer is ductal carcinoma. You all with me on this?
I had something similar like that happened to me, and I breastfed. And when my son was 10 years old, I was still having milk come from the one breast.
Mm-hmm.
So they did some tests, and it was coloniotomy. I hope I'm saying it right. And it was a cell that never stopped producing, so they went in and did it.
Yeah, to remove it surgically. Yeah, it could have been. So the reason that breastfeeding is preventive these are prevention. Yeah, late menarche. I want to start with late menarche. And I have another slide, and I just realized I didn't put it on here, so I'm going to have to draw it, and that's too bad. This is really, really interesting. See if I can find it in here. I don't know why I didn't think of that when I was going through here. I don't want to draw it. It's not there. Not there. See, I've got a lot of slides blacked out so that we can get done quicker. Oh, this is it. Okay, very good. How many know the name Mervyn Harding? Anybody? Well, I won't. He's a wonderful. He was a medical doctor, and halfway through his first year of medicine, somebody died at the medical school, and the dean called him up and said, "Would you come and teach?" And okay, he came to teach, and he just loved it so much. That's all he did the rest of his life. He got an MD. They sent him to Harvard to get a PhD in nutrition. They sent him to Stanford to get a PhD in pharmacology, and he got a doctor of public health at this all. So here we're sitting at this guy's feet. He's as humble as all day long, but he put this, and why didn't I see that? But I saw it right there. This is the one I want. Why did it not do that? I'm going to have to do it. It's strange. So I'll just have to show you the parts. What we have here is protein intake. So this is no protein, and this is more and more protein that we're eating. And this is lifespan here. And these lines, these yellow lines, separate puberty from childbearing years, menopause, and death. For men and women, except, of course, men go through puberty, no childbearing and menopause. But so this is true. This is generally true for men and women both. But what's going on here? Let's see if I can grab that line and move it up here. Can you see that death occurs later for a low-protein diet than for a high-protein diet? Y'all with me on that? And in fact, puberty occurs later on a low-protein diet than on a high-protein diet. Whoops, got the wrong line. Than on a high-protein diet. Y'all with me on that? And the reason I wanted to take the time to tell you a little bit about Dr. Harding's background is this man is a wonderful authority on almost anything you can imagine in medicine. And I had the privilege. He was the professor for a number of our classes in public health nutrition in graduate school. So the idea then, friends, is that if someone is on a low-protein regimen, let's say this little girl, and I'll use our girl as an example. In fact, I think you're aware, depending on whose data you look at, and there is a distribution, but the average age of menarche now is 11.2 years. Y'all with me? When you start menstruating, yeah. I'm sorry for the big word. And you all know that you hear more and more about girls, younger and younger, that start cycling. And so I don't know that I ever raised my hand, or I've sat with him many times to just talk about whatever, but I don't know that I ever asked him the question. But in my mind, at least, I had the idea that it might take several generations for this to happen. But when our first daughter was born, after she was around 10 or 11, we talk about it once in a while, she didn't start cycling till she was 16 years old. And I'm confident that it was the fact that we raised her as a vegan. Whether we did that's the reason or not, she didn't start cycling till 16. How many cycles did she miss? Let's say it's just let's say it's a month instead of 28 days. How many cycles did she miss? 5 years times is how many? 60 cycles, folks, where her body was not making 1,000 errors in her DNA. This is the reason that late menarche is a indication of less likelihood of cancer. Y'all with me on this? We call this copy error, and when I get to biology class in heaven, I'm going to say, why didn't you make this so you don't get copy error? But this is real. Everybody in the field knows about that. Now, yes, go ahead.
Question about DNA, ACTG,
Mm-hmm.
and 1 out of 1,000 goes bad.
There's various kinds of mutations, and sometimes it's just another methane molecule that gets hooked in there, and the right half rung is there. There's various kinds of mutations, but whatever they are, they end up messing up the shape of the protein. You understand, folks, that it's the order of these letters that determines the shape of the protein, correct? And so if the protein is misshapen, sometimes it's misshapen such a tiny amount it can still do most of what it's supposed to do, but a lot of time it's not.
So the defective wrong stays in place, but it's defective. For example, the A is defective. It stays
Well,
in place, or
it depends on the type of mutation. Sometimes it's actually a different half rung, if you will. There's a chemical name for it, that is the mutation.
so the question is, I always thought of the A's and T's are good.
Yeah,
C's and G's are good.
right.
So if it's a C that you pick, or it's missing, isn't it automatically filled with
Well, like I say, there's various ways this happens, but if this was a C and it ends up after the mutation as a G, whether or not this got changed, I've not heard anybody say. But the point is, we know there's a mutation. It's pretty easy to detect these days with the tests we have, and it causes a misshapen protein. Now, menopause, the earlier menopause occurs, the better we would like it. So this line here is affected by other lifestyle factors, so there can be an early menopause, which you understand why that would be useful, right? Because there's less copy error going on. And this is kind of nice. You live longer. On a what kind of intake in your diet? Low protein. Now, I'm not going to do a lecture on protein because they're going to run me out of town tonight. Well, tomorrow morning. And so let me just say this much. The average American is getting 10 times as much protein as they need, and it's bad for them. The idea that, in fact, there's a really neat, I just listened to it from McDougall last evening, and I was going to make a copy of it. Maybe I'll send it to Kathy. You should listen to him on YouTube. Boy, I could probably find it in a minute if I look, but I don't want to waste too much time. But the simple, you talk to any trained nutritionist, they all know this. 50 grams a day for a regular-sized person is absolutely, completely adequate, and it could even get down to 20 grams and it would still be adequate. The idea that we have to try to find a way to get protein is just absolutely scandalous. If you eat enough calories of any plant, did you hear me say this before? You will get enough protein, way more than you need. It's insanity. And when you look at this diagram here that's on the screen, you can see this is crazy stuff that the world has foisted on the public. You need a lot of protein.
So, when you talk about eating soy, which is supposed to be really good for us.
Eating,
Soy.
oh, soy. I'm going to come to soy. You can't get too much protein by just eating whole plant foods. Let me say this. You can get more than you need, but you can't get too much. If you're not gaining weight and getting too much food, you will not get enough protein to harm you. But Americans are getting around 100 to 120 grams a day. It's causing all kinds of problems, including an increase in cancer, aside from this mechanism right here. So back to our list of prevention factors. There it is. And so what's the deal with breastfeeding? How does that affect this? Most women, I don't know if you know this, but some women keep cycling while they nurse. But most women do not. And so there you are without the cycling and the added copy error. We have no idea why first child before 30 makes less cancer risk. But it's absolutely clear in the research. So if you have kids or grandkids that they're planning on children and they're getting up to 30, they need to get on with it before too much longer. Virginia and monogamy. The main thing I'm thinking of here is cervical cancer. You all know it is a sexually transmitted disease. There's probably a bunch of you in this room that have been were virgins when you were married and you have been faithful to each other. The chance of the female in that couple getting cervical cancer is virtually zero. Are y'all with me on that? And of course, if you've done other things besides that before, now you just have to live with what it was. But what about heredity? I'm going to look at this more in a few minutes, but there's these genes. How many of you ladies particularly, but men too, have heard of a gene called a BRCA1 or a BRCA2 gene? Only 4 hands. The reason that the story behind this was it was discovered that somehow this gene was related to breast cancer, so they gave it BRCA for breast cancer. They now know that this gene in females is related to all reproductive organs, cancer in reproductive organs. And then they found out it's related to reproductive organs in men. Men have fewer reproductive organs, but this gene, and I'll explain why, can be mutated. I'm going to put some X's here, and I'm suggesting mutations. Are you all with me on that? And when there's mutations in this gene, people get more cancer. A really good example of this, because I am not a moviegoer, I didn't know who Angelina Jolie was. But she found out that because of the mutations and later on they found another similar one, so this became BRCA1, and now there's BRCA2. Are you all with me? She found out that because of the mutations and you understand, folks, it's every cell in the body except red blood cells. Every cell in the body has the same DNA, except there's mutations and different ones in every cell. Are you all with me on that? But essentially, we have the same DNA from mom and dad in every cell. And so every cell in her body had the mutations in this gene to the point where instead of her risk of getting breast cancer being 11.2%, which is the average for American females, it was 87% chance. So she had surgery, and if it was my wife or my daughter and that surfaced, I would have encouraged that. Now, what does a gene do? Somebody speak to me. What does a gene do? That's part of it. The proper answer is it codes for come on folks, a protein. Are you all with me? And the protein that the BRCA1 gene codes for is the one I showed you a picture of. It's a protein that fixes, put quotes around that, mutations, repairs them. I'm going to just abbreviate it. Are you all with me on this? So if there's mutations in the BRCA1 gene, what might happen to that fabulous looking protein I'll actually show the picture again, what might it not be able to do? To do the fixing. Or it might be able to do the fixing less as well, see? So this is what's going on here. Now, since that time, we have discovered a score of tumor suppressor genes. I didn't tell you that's what they're called, but does that name make sense? That gene codes for a protein that fixes DNA mistakes. Every time a cell is copied anywhere in your body, these guys come along and try to fix all the mistakes. It's an amazing story. Again, I'm wondering just why it worked that way. Why not just make them so they copy without error? You all know about radiation and its dangers. I'd love to spend a whole lecture on radiation. That's my world. My graduate degree is in nuclear physics. That's all about radiation. I'd love to talk to you for a long time, but we'll just leave it. Vitamin D is helpful. Limited use of hormone replacement therapy. Do you remember? It was in 2004. A Women's Health Initiative study, I think it was 120,000 females were looked at in this country, and all of a sudden, everybody heard on the radio that, I can remember hearing it on the radio on my way home, that hormone replacement therapy, instead of reducing heart disease, guess what? It made it worse, and it made cancer increase. Overnight in this country, 35% of the HRT was abandoned by females. Now, there are times when the symptoms are so strong that a short period of HRT, doctors would say, I think that's probably worth doing. We don't have study on laughter. It's pretty hard to do a double-blind, placebo-controlled study on laughter. But there is quite a bit of, what do we call it, information that looks like that would be the case. Even stress is difficult to measure. So we don't have really good studies, but it's quite likely that this is correct. As much as Americans love caffeine and they love to find research that says caffeine is good for them, it actually is a factor as a cancer risk. And here is Is this the one? You need to listen to this, and I'll email this to Kathy, and if you're interested, you can listen to this by Dr. Greger, I think it is. Okay, let's keep going. Most preventable after lung cancer. Everybody knows, quit smoking, it just about stopped lung cancer. But the next thing that's easiest to prevent is colon cancer. They begin in polyps. There's the rules I already gave you. And we'll go from there. How many of you read the book, The China Study? About 6 of you. I'm going to enlarge this picture of China. What we have here is every little line, no matter where it is, makes not a circle, but an enclosure, is a county. And what Campbell and his associates, of course, did from China hired thousands and thousands of people to go to stay in somebody's home. We'd never do this in this country. The government forced the people to let this person live in their home for 4 days and wrote down everything they did and when they did it. Now, that's a great way to get data. Not very popular in a free country. But that's how this data was gathered. And what we're looking at, the darker the color in the county, there it's pretty light, there it's really light, there it's a little darker. Here in the cities it's really dark. The higher frequency of cancer there is. Y'all with me on this? So here is the amazing story. This is a summary. In the China Study book, there's a page for every type of cancer. But we want to look at the cancer rates in males and females in the county where the rate was the lowest and in the county where the rate was the highest. You get the idea? That's what the dash is about. So esophageal cancer in some counties was 1 case out of 100,000 people a year. In other counties, it was what? 435 times higher. And what they learned in this study, you know this if you've read the book, it has to do with lifestyle. Those people in the country are getting 2 things in particular. They're getting activity because they're growing their own food, and they can't afford to eat animals. You understand that, folks? They can't afford to even eat eggs. So what do they eat? Plants. This is astonishing, folks, the increase. And in the city, or wherever people are living like Americans, that's what this is from, just notice the ratio. 14 times as much. 20 times as much for all cancers. 35 times as much. 64 times as much. Is this amazing or not? Just because of lifestyle, and most of it is activity and diet. 75 times as much. In this country, if there's a cancer cluster where there's even 4 times as much of a certain cancer in a town, the CDC goes bonkers. They come out in droves. What's causing this big increase in cancer? Look at what it could be or is because of lifestyle. This is astonishing. You probably know this. What we found was shocking. Low protein diets inhibited the initiation of cancer from aflatoxin. Notice this, regardless of how much of this carcinogen was administered to these animals. Isn't that amazing? What kind of a diet? Low protein, folks, is the great plan. And the only way to get that is to use plants instead of animal products. All animal products are high in fat and high in protein. And almost no carbohydrate. It's just crazy how uninformed Americans are.
So when you're saying proteins, you're not including things like tofu.
I'm talking about an actual molecule of protein that is in every food we eat. Protein is a string of amino acids folded up into a shape to do a job. That's what I'm talking about. And when we eat food, we eat protein. And our bodies cut those proteins up, you know this, right, into amino acids, and our bodies make our own proteins. The point is, when the protein intake is high, which only comes from animal products, we get all kinds of problems, not just cancer issues. we found that not all proteins had this effect. It was milk protein that promoted what? All stages. Now, I've not talked to you about the stages, even though we've kind of touched on it. The first stage that is a cell that becomes cancerous because of mutations. And the next stage, and I'm going to show you this, but I'll just mention it. One of the reasons why cancers do not grow in our bodies when we're living wisely is because it takes a growth promoter to make the cancer grow. You can have cells, cancer somewhere in your body, never becomes a tumor. Now, you gals might be interested to know this name, Susan Love. Just put it down on your notes and look up her website. I have such respect for this gal. She's a surgeon, and her life is dedicated to doing whatever she can to eliminate breast cancer. And she has all kinds of good material, but she's well informed about this issue that cancer will not grow if there's not a growth promoter. And guess where most of the growth promoters are in our diets? Animal products. Not all protein had this effect. It was casein. Oh, all stages of the cancer process. Mutation. Enough mutation so that cell finally becomes a cancer cell. Remember, there's no exception. It's usually a series of mutations that makes a cell become a cancer cell. One of our own cells. I'm sure you all know about that. All right. This is repeating that. Successive mutations in the DNA. The average cancer cell takes how many days to divide and copy itself? We talked about that. About 8 years before the tumor is large enough to be imaged, or 10 years to be palpated somewhere, right? I was sitting in the room with my radiologist friend. He was doing mammograms, and here was a little tiny dot in the mammogram today, or the last day or two, and he pulled up the mammogram for a year ago, and the same dot was there. What do you suppose he said? It's not cancer. But if that dot was there and it wasn't there a year ago, then he wants to do some more work. So, but again, there's a problem with this because cancers are being overdiagnosed. But the bad news is that by the time a cancer is found, folks, this is horrible. It is already spread. It's rare. I'm a cancer survivor. I was diagnosed 22 years ago. It will soon be 22 years with prostate cancer. Probably got it because I was raised on a ranch. Do you know there's data today that shows that if you drink 3 glasses of milk, even for one meal a day, but especially if it's all 3 meals, it is a huge promoter of finding cancer in that person's body. And that's what I did. We lived on a chicken ranch, and we had cattle, and I drank 2 to 3 glasses of milk at every meal. What did we think back then? It was good for you.
How does all this affect skin cancers that you get from too much sun exposure?
Yeah, skin cancer is almost entirely caused by radiation from the sun usually, but you can get skin cancer from radiation treatments too. But skin is also living tissue, and you can get skin cancer from the other pathways, but most of it, as you all know, comes from radiation from the sun. So this is sorry news, but this is the truth. During this time, the tumor usually metastasizes. So when I had surgery, they take the prostate out, and you probably wouldn't know this. I didn't know it. They have a little jar of ink, and they drop the prostate gland that they removed into that jar of ink. 20, 30 minutes later, they take it out and freeze it and section it. And you all know about this, very thin slices. And the pathologist looks all over every one of those slices. And this is the report. It's a long report, but I have memorized the important part. It said, the adenocarcinoma closely approached the inked surgical margin. No transection was appreciated. You understand? When he looks across there with his microscope or her microscope, he can see where the surgeon cut. He can see the ink. And they only leave it in there so the ink is kind of on the surface. So the ink defines the surgical margin where the knife cut. Y'all with me? The adenocarcinoma closely approached the inked surgical margin. No transection was appreciated, i.e., they got it all. Y'all with me? Pardon? Perhaps. Prostate cancer tends to grow very slow, but your point is well taken. Then my urologist said to me, you have 5 years before you die. Why did he say that? Because he knows that cells always get away from tumors. Are you all with me? This is the bad news. Now, he wasn't lying. The average American man who gets prostate cancer and has that particular, if you will, diagnosis is going to be dead in 5 years from prostate cancer. He didn't know, and I didn't argue with him. I didn't even bring it up. I was aware from my training that a plant regimen makes cancers grow slow. I am 22 years downstream. Did you hear that? And interestingly enough, I'm not sure how useful this is, but I think possibly. During those 18 years, 19 years, 3 years ago, my urologist found a little tumor sitting right where my prostate had been. So even though they got it all, there was some cells that got out, right? And actually, I think this is useful to kind of know these things. You all know that physicians want to measure the PSA, prostate-specific antigen, in men's blood, because if the PSA starts rising very rapidly, the suspicion is that that's probably being caused by cancer. You all know about that. When the prostate is removed, the only thing that makes PSA now are cancer cells that got away. Are those cancer cells that got away, are they prostate cells? Say yes. Are y'all with me? And those cancer cells are out there multiplying and making PSA. The average American male after prostate surgery in 1 year, and let me just back up just a second and say, normally after surgery, there's no PSA detectable in the blood. Are y'all with me on that? You got to wait 6 weeks for the PSA that was already there. The average American male after prostate surgery has a detectable PSA in 1 year. What does that mean? There's cancer growing. In my case, it took 7 years. Why did it take so long for the cells that had gotten away, are y'all with me on that, to multiply enough so that there's enough PSA? You understand, tests for chemicals in the bloods have a lower limit. You can't test it for it. You can't find it if it's below a certain threshold. Does that make sense? So it was there from the time of my surgery, right? But it took 7 years for enough prostate cancer cells to copy themselves to be making enough PSA to be detected by the test. And I'll have to confess, when the letter came in the mail that year, I was feeling kind of bad, you know. So my urologist now in Spokane, and if I ever had a friend somewhere, a man who was struggling with these things, I am so impressed with this fellow, I can hardly describe it. But he did find a tumor about the size of, maybe a little larger than the tip of my little finger, sitting right where my prostate was. And he said to me, if you treat that with radiation, and I don't want that, you understand that, right? I actually know more about radiation than he does, but he said that tumor will disappear and your PSA will go to 0. because my PSA had been rising slowly, like I said, after 7 years. So I don't know. So I think some of this is not only interesting, I think it'd be useful. I had never heard of this before in spite of my field. There was a brand new kind of radiation called IMR, intensity modulated radiation. It's a device. You guys remember when you used to have cameras that had an iris? This is like an iris that can form any shape needed. Got it? Not just a smaller or bigger circle. And you probably don't know this, but these radiations that are used for cancer or whatever else, they're very high energy, and they don't disperse. If you shine a bright light through a hole, it'll spread out from a process, don't worry about this, we call diffraction. But the energy of these X-rays is so high that they stay absolutely straight lines. And they get a model of that tumor with CT scans or MRI scans. So they actually have a mathematical model of that little ball, and they put that in the computer, and they take this radiation machine on a gantry, which just means it's a thing that can circle all around you and shoot you from any direction. And every time that the gantry moves to a new position, those little guys change, and it's exactly the shape of the tumor from that aspect. Is the tumor a different shape from wherever you look at it from? Yes, because it's not a ball, right? And I didn't want to do this, but I decided that maybe that was okay, especially because, why are they doing this? To reduce the damage to tissue, so that you're spreading the damage all the way around instead of from one direction. I asked him when he suggested that, I said, well, what about proton therapy? Again, you understand that's my world, right? And I don't know if I should tell you this, but what happens with the proton beam, it travels through tissue and doesn't lose any energy until a certain place. Now, what would be important about me saying it doesn't lose any energy? It doesn't hurt. It doesn't hurt anything. And then there's this thing called the Bragg peak. This is nuclear physics, where all of a sudden it loses all of its energy. What does that mean? That's the place. You want that to happen at the prostate. Are y'all with me on this? And so they build a plastic mold based on how much tissue there is, and the traveling through the mold and your tissue, and of course they have you fastened in this whole thing, you try to get the Bragg peak to be right where it's supposed to be. Does that make sense? And it's never perfect. I was aware of that, but he said to me, Jim, the proton will do more damage than the IMRT will. So I called Loma Linda, and a lady answered, bless her heart. And I told her, I was asking, do you guys have an IMR machine? Intensity modulated radiation therapy, IMRT. Yes, and she said, but you should get the proton treatment. And I said, well, thank you very much, but I'm planning to do the other. But you should get the proton therapy. Anyway, so it's no fun. It messes with you. There are side effects. But the tumor completely disappeared, and my PSA went to 0. So pretty interesting. Within a couple of years, it started creeping up from 0 again, if you will. And so, but my urologist, the man I'm talking about in Spokane, and I'll say again, he's just such an outstanding guy. He says, Jim, I am not worried about you in the least. You will never die of metastases from prostate cancer. He knows my lifestyle. And it's amazing to me that in the standard trained physicians out there are some who have educated themselves. And he said, I'll repeat it. I am not worried about you in the least, he says. PSA is the abbreviation for this substance, this chemical that prostate cells make. All prostate cells make it. But when they become cancerous, they tend to make more. So it's been a diagnostic tool, at least to take another step and see with the biopsies and so forth. I don't know if we should spend any more time on that, but you may know that there can be a cancer in the prostate and you can shoot 20 needles through and miss it because it's a little tumor in there. So there's other issues in this whole thing that I'm not sure we need to discuss that much of. Yes?
You mentioned when you first started talking about this, your condition is that the PSA normally takes a year at a certain level to 2 through 7 years.
That's correct. And the reason is,
The difference is, I assume you infer it, that's because we're not taking the animal protein necessary to fertilize that growth of your lifestyle.
to accelerate the growth. And it's not just the protein. Almost everything you look at in a plant regimen.
Animal protein. We're taking animal protein.
No, let me finish. Almost everything you look at in a plant regimen contributes to slowing cancer growth for most all cancers. So you look at the protein, you look at the carbohydrates and other things in the plant, like any one of the over 10,000 phytochemicals. You guys know what I'm talking about? Everywhere you look, you see a benefit, and you don't get, you know how much phytochemicals there are in animal products? 0. And we know of over 10,000 of these things, and they all turn out to be beneficial in various ways. Does that make sense what I'm trying to describe? Yeah. Now, the phases are initiation. A cell, because of a sequence of mutations, becomes a cancer cell. And then, this is the big deal here, folks. I mean, among the big deals. There has to be a growth promoter to make the cancer cell grow, and every cancer has its own growth promoter pretty much. Let me give you an interesting example. Do you know what I'm talking about? Something that makes the cancer cell grow. And if you can eliminate that something, that tumor may never grow at all, or so little. Doesn't everybody know that asbestos causes lung cancer? That is incorrect. Asbestos is a growth promoter, period. So some man, whether it's from tobacco smoke or just metastases that happen all the time, gets a cancer cell somewhere. He doesn't know this, of course. I say man, some person. If that smoker, let's say most of the time it probably was the result of smoking, if that smoking man or even a former smoker never gets exposed to asbestos, that tumor probably will never grow. Are y'all with me on this? So mesothelioma is not caused by asbestos. It's caused because his smoking or some other source made the cancer exist, and then the growth promoter is asbestos. Is that all clear? Yes.
What are other growth promoters? Are they almost like lots of everything? So
Yeah, most everything we look at in the standard American lifestyle turns out to be a growth promoter in some way. And most everything we look at in a whole plant regimen active person turns out not to be a growth promoter. It's remarkable, absolutely remarkable. And of course, T. Colin Campbell became famous for the studies he did that animal protein makes these tumors grow. It's amazing. That's what he says. Now, that needs a little bit of adjustment. It didn't turn the growth off completely. My body is still making cancer cells. Are y'all with me? My PSA is very slowly rising. And I won't repeat what the urologist said, but it's because he knows the growth promotion is so minimal in my body. He says, I'm not worried about you. It's amazing. And it's actually good news. You understand that? Progression, we just use these words to describe these three phases, is when the tumor starts to send cancer cells out. And it's a horrible thing that happens, but everybody knows about that. That's the same thing, a promoter. Using a macrobiotic diet, emphasizing, now this isn't the best, but it's interesting what happened. This study was done years ago now. Using a macrobiotic diet, emphasizing whole grains, vegetables, legumes, while avoiding dairy products and most meats, 9 men with prostate cancer lived 19 years after the diagnosis. And an equivalent group of men, in fact, it was a group of men with essentially the same situation, and they divided them in halves and fed them differently. The other guys, the standard American man, lived how long? 6 years instead of what? Isn't that amazing? And that to macrobiotic diet was not as good a diet as we're talking about. And look, did they get a little meat? Are y'all with me on this? The other group. So, very interesting. And there's the citation for that. This is talking about the size of things. I'm going to pass these up, and I think we can kind of quit pretty quickly here. There's an awful lot of slides left, but we've got to read this, and then we'll talk about soy, and I think we'll try to quit then. Let me give you a quick background. You've all heard how soy is bad, helps cause breast cancer and whatever. It's just amazing, folks, how wrong that is. And there are so many people that I know in churches where I go who, I don't want any soy milk, and I don't, all that. But here's what's going on. By the way, there's essentially 4 kinds of breast cancer, what we call ER positive, estrogen receptor positive. What that means is, here's a cell in the woman's body that it becomes cancerous, let's say, and because it has an estrogen receptor here, this is a protein, right? When that protein is occupied by, I wish I used a different color, estrogen. Are y'all with me on that? You can't see through me, I understand. It makes that cancer grow faster, so we call it an ER positive tumor. We call it a hormone-dependent tumor because you can try to block estrogen from getting to that receptor, ladies, with what kind of a chemical? What's it called? Tamoxifen. Tamoxifen is a chemical that we manufactured that receptor will grab. Are y'all with me on this? Y'all with me? Not sure? You understand that the cell has receptors, proteins sticking all over the place, and they do their job usually by grabbing something, right? And then something happens inside the cell because the receptor grabbed that protein. Y'all with me on that? So an ER positive tumor is one where if the estrogen receptor gets estrogen hooked to it, I'll use a different color. I'm sorry, I need to do this on a big board. I like when the church have a great big board that I can draw on. But anyway, so let's say this red is a little chunk of what? Estrogen hooked to the estrogen receptor, which will now make this cell, this cancer cell, grow faster. Y'all with me on this? It's an ER positive tumor. Now you could have an ER negative tumor, which just means that estrogen wouldn't, if it hooks to it, it's not going to make it grow faster. Are y'all with me? Then there's progesterone, positive and negative, and HER2, positive and negative. And progesterone, of course, is a hormone. Herceptin is not exactly a hormone. And so, have you gals ever heard of a triple negative tumor? Never heard of that? Not a single woman? This is the most dangerous kind of breast cancer there is because you can't treat it with any hormone kind of treatment. And it's lethal rather rapidly if it's a But 95% of breast cancer is ER positive. Y'all with me on that? And estrogen, do you know this? I'm going to use the proper term, estrogen-like compounds made by plants. Are you aware of that? Well, you're aware now. It's one of the phytochemicals, one of those 10,000 chemicals. And I don't know who did this. This is kind of maddening because this is so throughout the fabric of society, you want to just scream, come on, people, get yourselves educated. But anyway, some chemist or somebody somewhere, without thinking or was completely uninformed, decided that plant sterols, the better term is an estrogen is in a class of chemicals called sterols. And plant sterols are estrogen-like chemicals. And whoever this was, man or woman, got on a podium somewhere, I suppose, and said, don't eat plants, especially soy, because soy is higher in sterols, but every plant has some plant sterols in it. Are y'all with me on this? And because that plant sterol is going to do the same thing. And when I heard that, I thought to myself, I don't think that's the case. And I'm so fortunate, folks. I told you this man's name. You remember the name Mark Messina? He is the world's authority on soy. And we met him, I think I told you, because he and his wife came to the restaurant. We became friends, and I have his phone number. And whenever I have a question, I just am so thankful I can call somebody that's an authority. And he said, oh, listen, Jim. At first, we didn't know this part. He said, I'll send you a page, it was on email, with a page full of references that dispute this. We didn't know why at that time. That plant eating was not causing this to grow faster. Y'all with me on this? We now know that there are other receptors, and we'll probably find a lot more of them someday, that the plant sterols occupy. I'll just put PS. The plant sterols or estrogen-like compounds. No, not estrogen. Yes. They occupy this receptor and make the cancer grow slower. I'll bet you'd have to ask 10,000 people on the street if they know about that before you'd find one person that knew about it. It just makes me want to scream. I have another friend, a physician back in Maine, and most of you will know this name. Some of you know that I worked for Neil Nedley for 2 years, and we became close friends. I was the vice president. I think I told you that. Anyway, Neil Nedley said to me one day, because he knew I had met, in fact, my wife and I have stayed in this fellow and his wife's home. Tim Howe is a physician. And this is what Neil Nedley said about him. Jim, I think he's probably the top most internal medicine doc in this country. And I've been with him enough and asked him enough questions, and I've sat with him in his office while he is working. And so I called him up one time. There was this gal that had breast cancer and came to talk to me after my lecture. And I made some suggestions, and I just wanted to double check. And so I called Tim, told him the story, and he said one thing to me. He said, Jim, make sure that she drinks at least 3 glasses of soy milk every day. It helps make the cancer grow slow. Isn't this insanity? And even at Adventist potlucks, there's a place where it says soy-free, and I want to say, cut it out. Put more soy out there.
And you know what, I was just trying to pull up in my brain how the soy food was presented negatively.
Yeah.
Excitotoxic.
Yeah. Yeah, this guy, Blaylock, since you brought it up, this physician, I read his book, and all the way through the book, I'm just saying, I can't believe this. But I have 2 friends who are neurologists. I got a lot of friends out there. One of them is a shirt-tail relative through marriage. And I asked him about this. I've asked several people actually, and he said, Jim, I can't imagine that this idea that making a nerve cell fire would cause it to die. That's what Blaylock claims. In case you don't know, excitotoxins supposedly are chemicals in foods that make nerve cells fire more rapidly, and that the nerve cell will then die. And I know a fair amount about brain chemistry. That's been one of my most favorite interests, and it is just so far from reality. But I still like to ask people that are experts, right? So just mark that out of your notes. Yeah. Neva is pointing to her watch. What does she mean by that? I did early on, and I said that the problem with insulin resistance, were you not here when I said that? Is that let me just make sure. You understand that insulin resistance makes insulin levels high in our blood, in our bodies. And that high level of insulin is all in the brain as well as everywhere else. And it is quite obvious that it's a big factor in causing dementia. So what's the number one risk factor for Alzheimer's disease? Type 2 diabetes, which in the big issue there, besides circulation problems, is this elevated level of insulin over years of time before they were even diagnosed, right? And what do they start giving these people? Now, you know they give them metformin these days, but when they can't control their sugar with that, what do they start doing? Insulin. More insulin. It's just terrible. Yes, dear.
Well, I know what you're thinking, that covers, the whole thing for us, but maybe because of these specific, things that need to be done, like, exercise, walking.
Yeah, you probably are aware of this. Almost anything that happens to people that are bad, activity makes it less or not occur. And the whole plant regimen is the rest of the answer. Yeah, and lose weight, get normal weight. And go ahead. Say that again. I'm not getting. I'm not getting the word. Is that a medicine you're talking about?
Yeah, Invocana.
I'm not familiar with that one. But here's the thing, folks. If you have or anybody of your friends have diabetes, you can get well in a few days or a couple of 3 weeks if you follow this lifestyle. We see it all the. What did John McDougall say about type 2 diabetes? 100% is reversible. And we see that in our work. So use the medication the doctor gives you while you're getting well, or whoever it is in your family that has it. But you can get off those medications quite quickly if you will follow this lifestyle. Another hand. I mentioned intermittent fasting already is a factor, and I told you that I would send Kathy the link for Dr. Kolova, I think is the Russian lady's name. Did I not say that here? Did I say that somewhere else? Where was I when I was talking about that to somebody? Anyway, not Norman McDougall. Who's the guy that started the Physicians Committee of Responsible? Neil Bernard. Neil Bernard's, the director of his research is an Adventist Russian lady, and I've listened to her lecture on this. She designs and executes a lot of research that Bernard raises money for. It's very interesting. And they did a whole lot of work on intermittent fasting. And it's very good data. And you can listen to her lecture and hear it. But it's a very effective.
Is it an effective way to lose weight? Intermittent fasting?
Yeah, it's a very effective thing for dementia of all kinds, but particularly Alzheimer's, which is the big issue in dementia, as you know, in this country, in the world. Why? Oh, well, yeah, I don't have technical knowledge. I know the lay description that they use. And maybe in her lectures, she talked more technically about this than I don't remember it. But apparently, when the digestive system is settled down and not operating, the circulation in the body facilitates, this is a lay term, cleaning up debris in the brain. You understand that we're talking about metabolic process. Anytime any chemistry takes place, there's always chemicals that are left over, and some of them are needed, but some of them are not, and they need to be cleaned up, if you will. That's a lay term for sure. But that they believe that's the mechanism. They know from the research that intermittent fasting is an effective thing for dementia. So they usually talk about 18 hours, and we try to follow that. We try to have breakfast at 7, and then we try to eat at 2, and so if you take the time until 7 o'clock the next morning, you get this this intermittent. It means from time to time you do that. Fasting all at once for 21 days or something like that, in my opinion, is a crude, almost useless thing. People live like HELL, and then they go on a fast and it helps them some. And then what do they go back to? The same terrible lifestyle. That's not the answer, folks. The answer, and the research shows it. And you know that Ellen White talks quite a bit about, she doesn't use the term intermittent fasting, but if you read what she says, she's talking about that, to skip a meal. So now I don't think that Dr. Kolova, and that's not quite her Russian name, but it's close to that. I'd have to listen again. Is 12 hours useful, even though you didn't do 18? I think the answer is probably yes, but I don't remember her discussing that. She did talk about how late the second meal could be and still have it be useful, as long as there was some time for the next one. She did talk quite a bit about that.
How late could it be?
She said the research showed as late as 4 o'clock, maybe even a little later, and they still saw some result from that. Somebody else?
I heard, I know that, I think the time frame you're talking about is when you go into autophagy.
Into what?
Into autophagy is where you're starting to repair your body.
Uh-huh. Yeah.
And it'll take all the junk in your body and create new proteins.
Yeah, that's a very good lay description. It's all right. But for some reason, the digestive process, one of the things I think it takes a lot of energy. And there may be other systems that just can't function very well until that energy is available to perform this stuff. So pretty interesting. My wife is waving frantically at me. So, yeah, and besides that, she's going to show you how to make potato chips without putting oil on them. So it's been fun being with you all this week, and God bless you. Follow that lady. Oh, I was going to read you this whole thing on soy. I'll send it to Kathy. It's really good. Don't let anybody see that I did that. It really doesn't matter when you've got a cord tough like that.